Okay, thank you, Leo, for the introduction. I hope that everybody's hearing correctly. I'm going to wait a little bit more just to see whether a few more people are going to join, and then we can start immediately. Meanwhile, if you are already here, so thank you very much for coming. I have a lot of fun preparing this presentation. I also learn a lot. This is one of the reasons why it's good to give presentations, because you kind of have to investigate everything so that you are able to answer several questions. Okay, so for the people who is arriving now, if you have questions, feel free just to add comments and put text on the chat. Unfortunately, I'm not going to be able to do a presentation and read at the same time. I cannot multitask while presenting. So, and well, in general, I cannot multitask. So, but put all the questions in there in the comments, and I will read them at the end and try to answer all the questions that I can. So, unfortunately, I get a message saying that you're no longer a host. So, is that correct, Leo? All right. Okay, good. So let me start. So there are already a good amount of attendees, so I can start talking. In the beginning, it's just a presentation about myself, so you're not going to miss the people who is going to arrive later. Is not going to miss anything about the real content. So my name is Boriss Mejias. I'm a holistic systems software engineer. I'm also an air guitar player. The term holistic refers to my conviction that every time that we have to solve a problem, it is better to look at it from all the possible angles, not just in a reductionist way and then stop there. And in my view, the sum of the part, it is larger. The system is larger than the sum of all the parts. That's the thing. Well, of course, the term holistic system software engineer doesn't exist in an official title. So my title is solution architect. I work for EDB now, and we are a PostgreSQL company. As you can see, our slogan is power to Postgres, and one way of providing power to Postgres is also providing power to the entire community, and this is by sharing knowledge, and that's why we participate as well in Percona Live, because it's an interesting community, and we want to promote what you can do with Postgres. So this is not just power to Postgres; it's also Postgres powering you as a user. So what we are going to do today, it is to talk about role-level security. What I really like to do when I understand something is not just to go through the theory and then explain what you can do after you have learned what it is. It is basically to start with a problem. So you start with a problem, and then you can see how you can solve that with whatever system you're using. In this case, it's going to be PostgreSQL. So we are going to use a book here, The Hitchhiker's Guide to the Galaxy, which is the most remarkable book coming out of the Megadot of publications from Ursa Minor. So this book, it is a guide for travelers that go through the galaxy, and they're always carrying a towel. So if you're not carrying your towel, at least you have to know where your towel is. So this is very important. And in similar ways, very ways is similar to the Wikipedia, because it is being edited by multiple people. It's not just one central organization that produces all the text. No, this is done by the hitchhikers themselves. So they travel, they see places, and then they submit the entries for improving the guide. And it's also an electronic book. So it's really, if you have a look at it, it's very similar to what it is Wikipedia now. Of course, traveling causes that you have some expenses that you need to pay for. And well, now, in pandemic, we don't travel very much, but you know that when you finish your traveling, you do your expenses report and you hope that it's going to be paid back. Okay, so this is what we are going to try to solve. We're not going to try to solve how to write the Hitchhiker's Guide to the Galaxy, the book itself, but how to manage the expenses of the travelers that need to spend some Alterian dollars. They try to do everything for less than 30 Alterian dollars a day, but we will see how this is being managed by the Megadot publications. Right, so we start by analyzing the requirements of what I just explained. So what we want to have, it is that each hitchhiker can submit its own expenses reports. Okay, so this is one first condition. The next condition is that when you read the table of information about the expenses, you can only see your own reports. Nobody wants to see, well, some people want to see the expense reports of other people, but you don't want other people to see your reports, except for the people who has to review it and then approve it, of course. Now, we also want to provide the permissions to a hitchhiker to edit the expense reports, but only its own reports and only before they are being reviewed. I mean, if they are being approved, you can change the value and add more money, of course. So these are the requirements for the hitchhikers in the sense of providing the reports. Now we look at the management people, and we need to have people who can review the reports and then can see them all. Yeah. So this is people who have a special authority inside the organization. And then you also have another people, which is the supervisors. The supervisors, those are the responsible for approving or rejecting the report. So they are making a decision, yeah, about what is going on. So this is the requirements, and this is what we are going to try to solve with PostgreSQL. Of course, usually you solve this at the level of the application, and you just use the database to store data, not to do the logic of your business. So you have your users that connect to your application, and your application is going to connect with one single user to the PostgreSQL database, and then it's going to solve everything. That means that all your security for data access control has to happen at the application level. And this, well, is feasible. I mean, everybody does it, actually. It is quite a common way of doing it. The problem is that what happens if you have other people accessing your database, yeah? So are we going to work with application users, or are we going to work with the database users? In this case, just show you how to work with row-level security, because all the logic happens at the level of the database. I'm going to do the presentation with database users. If you say like, okay, I'm not going to do it like that, okay, it's fine, but learn how to use row-level security, and then at the end, I'm going to briefly show you one hint about how to do it with application users. So what you're going to learn now, it is not just for database users, it's also for application users. So there is normally the only single user that connects from the application to the PostgreSQL database, and we can still do this technique even if we use database users, and I'm going to show you how. So first question is, what are we going to do, application users or database user? We're going to do it with database users in this case, and at the end I will show you a little bit about the application users. Right, so we have a table which is for the expenses. This table contains, well, an expense ID, because you need to have an identifier for the entire row, which is a unique row. Then what we need to have, it is the name of the hitchhiker who is providing the expenses report. Yeah, this could be, I mean, if you have a reference table, it could be the ID of the user, but we're going to have the username. It's easier to read. And then you have the amount of money. We're not using any currency here, the data type, because this is Algerian dollars and this is not directly implemented in PostgreSQL. Now, the state, it is whether it's been, in the beginning it's new, as you can see, the default is new, but it can be approved or whatever afterwards. Then you have the date of the submission of the expense report and decided by somebody, okay? So this is the person that took the decision about it. As you can see, the only type that is not being highlighted with a bold text is the expenses state. This is because I created the type, and I recommend you to do the same. I really love enums, enumerated data types. I have all the presentations about enumerated data types because I really enjoy working with them. So in this case, I'm defining the type as all the possible states, and it cannot be anything different from this 4 states that I put there. It can be new, on hold, rejected, and approved, and that's it. I can modify the enum afterwards if I want to, but if I want to guarantee that my application is going to have only these 4 states, you do with an enum. Yeah. So again, this is the philosophy of putting part of the logic in the database itself. So you don't have to worry about testing this on the application level. The application can do the other things that are more important for the application. Here you have very good guarantees here. Okay, so hitchhikers submit their own expenses report. This is the first requirement that we have. So something that is very normal, the application is going to do it for you, but it could be done directly on the database. You say insert into expenses, the name of the hitchhiker. These are the 3 columns that you're going to do: the hitchhikers, the amount, and the date. Yeah. Look, I can use the mouse here. This one is generated automatically by the database. The state is by default new, and then we don't know who is going to decide about it. So we just need to provide the hitchhiker, the amount, and the date. Right, so I say my current user, and this is something that comes from PostgreSQL. Yeah, so if you say select current user, you get the value of your user that you're connected to. Well, I'm going to have a 42 Algerian dollars, and the date is now. Now it's a timestamp, but it's going to be converted automatically into date. Now, what if I want to provide some expenses report for People Brooks, which is a friend of mine? Well, this is not supposed to be allowed because it says that hitchhikers submit their own expenses reports, right? So you cannot provide expenses report for somebody else. So this is kind of something that you want to avoid. Now, what if instead of inserting something with these only 3 columns, I want to add the state immediately as approved so that it gets paid into my account? This is respecting the current user, so it's my own report, but I wanted to have it immediately approved. Well, this is what you call, and because this is about security, your threat model. Oh, so you have to be there scared about the situation. Of course, one of the other reasons why the Hitchhiker's Guide to the Galaxy have such a successful book is because it has written in friendly, large letters on the cover, don't panic. So in every threat model that you have in your security analysis, don't panic, try to see how you can solve the problem. Right, so let's continue with our problem. Another thing that we want to do is that each hitchhiker can only see her own reports or his own reports. What you will normally do will be like select everything from expenses where the hitchhikers is equal to the current user. So you get your current user, you can see only your own thing. The threat model again, what if somebody says, I want to see what Trillion is reporting as expenses? So this is something that you don't want to happen. Yeah. Also, what if you want to see from everybody without the where clause? You just say like, give me everything. And then you're going to see too much information, of course. Right? So this is actually our threat model again. So don't panic, analyze it, and then try to solve it. Good. So where are we going to solve it? One way to solve it, as we discussed, it is at the level of the application. So in the application, we can filter all these queries, and we say all these queries that we have identified as part of the threat model are not allowed, or we only allowed this one and the only one to talk to the application. Now, what if you have another application that also have access to this database? This application is just going to use whatever it needs. So if you want to have a security there, you also have to develop the same thing that you were doing for your application into that one. And of course, to keep these 2 modules in synchrony, it's not that obvious, of course. And even if you can do it, you also have other things like the PSQL, which is the console command line for PostgreSQL to access, and everybody getting access one way or the other could contact to the database and run the queries manually. And not only that, you also have things like OmniDB or pgadmin. So it is difficult to protect everything if you put the logic of the security on the application. So instead of having it there, what I recommend in this presentation is to move that logic to the database. If we put it there, then we're going to be able to protect it for any usage. So if you connect from another application or from PSQL or from OmniDB or pgadmin, you are safe and you guarantee all these things that I put at the beginning of the requirement. Aha. So before we go to role level security, let me give you a little bit of a global context, so the holistic view of security in PostgreSQL. So you can protect access to the data first by level of connections. You have 2 things here that are important: the listen addresses parameter setting in the configuration and the PG host-based authentication file. The listen addresses, it tells you, well, you have a network card or maybe multiple network cards, and this is what you say, I'm going to listen into one of them or into all of them. It's like when you have a house and you say like, I allow connections only from the front door, or you can say, I allow everything from the front door, the back door, the windows, everything. Yeah, so this is your first level of from where you're going to allow connections. If you don't allow anything, then only local hosts can connect, okay? Once you have opened that, you can control then from say like, I allow to this database with that user from that particular IP address. So you can filter that in the host-based authentication. So depending on from where it's coming, you decide which method you are going to use. I'm not going to go into the details. I'm just explaining you this onion of security that you can get in Postgres. So this is for the connections. Once you have entered into it, then you have the privileges that are managed by grant and revoke. You probably already seen this already. So you can do this at the level of the database first. Every database then has schemas, so you can also protect that at the level of the schemas. Once you enter inside the schema, you can protect at the level of the table. And once you enter into the table, you can start protecting at the level of the column. So remember when I show you that you have in the table who decided that it was going to be approved or rejected, you could say like hitchhikers cannot read this. So this information is not public. Or you can decide that the people who is evaluated cannot see who is a hitchhiker because they have to evaluate based on the expense report and not of who is sending the report. Now, this was all fine until version 9.5, and then we had an extended version for Postgres that was available, row security policies, which is the official name for row level security. So this means that now we can do at the level of the row, the security, and this is what I'm going to show you now. So if you combine the row with the column, you can actually be at the level of the particular cell inside the row and the level of protection. So this is all the things that provides you PostgreSQL. One of the reasons why I like so much Postgres. I'm a big fan of Postgres. So once you protect this at the level of the Postgres part, remember, it doesn't matter from where you're connecting, everything has to be respected because everything is at the core of the kernel. So let's see how we do it. First thing, it is to enable row level security. You don't enable it like globally, you do it per table. So you enable it, in this case, on the table expenses, you say alter table expenses and enable row level security. Who can do this? Of course, super users can do it always, but the owner of the table can do it. Now, the owner of the table doesn't have to respect row level security because he's the owner of the table. If you want to make it force also for the owner of the table, you can do it like this. You say alter table expenses, force row level security, and then everybody respects. So all animals are equal. Okay, some animals are more equal than others, and then you have the super users, of course, that can read everything. Now, it is important here to understand that as soon as you enable row level security, by default, no rows are possible to be accessed by anybody, yeah, except for the super users. So you need to start defining the policies now that are going to give you access. It's not like, okay, we enable row level security, but until now it doesn't do anything. No. If you do select everything from expenses now, after these two commands, you see nothing, 0 rows. So you need to start allowing access. So you start with something that is closed, and then you start opening doors. Instead of starting with something open, and then you need to close door, when you don't need how much you have to close, right? So let's put a read policy first, because we want to provide access to the data. What we are going to do is the following. So let's go back to the requirements. Each hitchhiker can only see her own reports. What we would like to do is this. Select everything from expenses where the hitchhiker is the current user. What we're going to do is to create a policy that enforces this. Now we have a guarantee that every time that you do select, it has to respect this. The policy says, so first you have to give a name to the policy, and better just give a descriptive name. Don't call them row level security policy 01, row level security policy 02. No, give it a name. Give it a name. Names are good. Check own expenses. And then you say where, and then you give a table on expenses, which is your table. Using hitchhikers, which is your column, is equal to the current user. Fine. So that means that I can only check my own reports. Perfect. So this query now is safe. If I do now, give me everything from the table, I'm only going to be able to see my own because it has to respect this thing here. Right, so I have a filter now. Perfect. So now it doesn't matter if I connect from the application or if I connect from PSQL. I know that this query is going to prevent me from seeing all the people reports. So we are protected. Good, nice. So let's see all the cases. What if I do reports from other hitchhikers? So let's say I want to say, select everything from expenses where the hitchhiker is Trillion. Well, I cannot, because Trillion, if it's not my user, my name is not Trillion, I cannot see it because I'm not respecting this one. So this one is also protected. Fine. I cannot try to add some extra thing to find stuff. So let's see an example. You have here the same policy that I just showed you. Now let me do set role, and I'm going to become user Arthur Dent. The result is being set because I was a super user. That's why you have a hash here. Yeah, the hash means that you have super user powers. And then I turn into user Arthur Dent. So if you can see here, I have a greater than. The symbol means that it's a normal user, not a super user. And I do select everything from expenses. And I see only 2 rows, and the 2 rows are with hitchhikers equal to r.end. Yeah. One is approved and the other one is new. So it's not being decided yet by Marvin. Good. So write policies now. We have policies now for reading data. Now we want to modify data in a secure way. So we say now, the requirement was that hitchhikers submit their own expense reports. So you cannot submit somebody else's report. This is what we saw in the previous slides. This is our threat model. So this one is not good. This one is not good. And this is what we are going to change now. So we create the policy, and the policy, it is now with a check. So the name of the policy is different. It says write on expenses on the same table. And we say with check. This is different than before. Before it was using. This is with check. Hitchhikers is the current user, so my own reports, and the state have to be new. So I cannot modify things that are not new. So I can only enter. So submit own expenses. This is new, right? So this query, then, it is okay with the policy, which is the query that we wanted to use. Insert into expenses. This is my current user now, and by default, the value state is new. Fine. So we respect what we wanted to have. Now let's look at the threat model. In the threat model, we have the first one that it has that I want to put an expense report for Sable people blocks. This one violates the policy that says hitchhiker is equal to the current user because I am not Sable people blocks. So this one is broken. That means that our policy protects us from doing this. Now the next one, where I wanted to add expenses report where the state was immediately approved. Well, this one violates this part, which says state equals new. So we are also protected against this one. 2 policies, and we already have a lot of guarantees. This is what I like. Now, update policies. So we have inserting data. Now let's see how we update stuff. We already have this policy for this write own expenses. And we can see here that we have now here, hitchhikers can update own report while new. This was also one of the requirements. That means that it's already covered here. I don't need to create anything else. This is already being covered by this policy. So let's try to do something. Update expenses, set amount to 1999, where expense ID is equal to 42. Well, if this one is my expense report, I am the current user, so it's fine. And it is, if I don't change the state and it was new, then it's fine. So I'm just changing the column, the amount. So this should be fine. This one is also okay if this is my expense, but now I'm changing, instead of changing the amount, it's exactly the same expense report. You see 42. The date is now. So I'm changing, I'm updating the expenses report because I put it wrong. So I need to put it as today. Good. So let's test it again. Can we approve my own expense? Yeah. So I will say update expenses, set state approve, where expense ID is 1,367,000, etc. This is for Prefect that is trying to get his own expenses report approved. And then it gets an error. New row, remember, an update is actually deleting the old row and creating a new one. So the new one is the one that fails with the check. It says, new row violates row level security policy for table expenses. And then you get an error, so you cannot update. Protected. Good. So let's see that I want to transfer now the expense to somebody else. Yeah, remember that the requirement was own expenses. In this case, we have, I'm going to first do select current user. Current user says r2then. So this is r2then who is running this. You can see here, that's why I put here the comment here, r2then. Now we get update expenses, set hitchhikers equal to trillion. So I want to transfer this expense ID 42 to trillion. It says, oh, error, new row violates row level security policy. What is the violation? Is that the hitchhikers is not the same as the current users. You see, current user is r2then, and then I want to set it to trillion. Well, wrong, fails. Good. So we have this protections, and it's tested correctly. So now let's see if we can, this is not steal, this is steal with an EA. There's a typo here. You cannot steal the expenses from somebody else. Yeah, so let's try this. I'm combining now 2 policies. The policy for writing, which is with check, and the policy for reading, which is using, okay? Now, I am current user is for prefect. Remember, the for prefect is kind of a dubious guy in terms of when it comes to money. And what he wants to do, you remember that the 42 was from Arthur then, he wants to set it to himself. So he says, update expenses, set hitchhikers equal to for prefect, where expense ID is 42. Update 0. This one didn't error out. Why didn't it error out? If we have here the check, it would have violated this one, right? But before getting to that one, it actually didn't pass this here because the update needs to read first to find where is this row with the expense ID is 42. But it couldn't find it because it didn't belong to him. So he couldn't do the select. So if he cannot do the select of that particular row, he cannot do the update. So the combination is very important here. And now let me explain you something about how policies are combined when you have multiple ones. So you have when you have multiple operations, like it is in this case, read and write, update is read and write, you have an end between the different policies with check and using. So both of them have to be true in order to allow the action. In this case, this one is false, so we don't even have to test the other one. If you have one single operation and then you have multiple policies for that one, so let's say that I have other policies saying using, then I'm going to do an OR. Within one operation, I do an OR, and then I'm going to have, like, if any of the policies satisfies the action that I'm going to do, then I said, okay, it's fine. This is true, so you can do the operation. So you have to combine them as an OR when it's the same kind of policy, and it's an AND when it's different kind of policies for reads and writes. All right, so let's get back. So we have now proven to you that if I put the security here, it doesn't matter whether I use an application with a web interface or whatever, or administration tools like pgadmin or EDB, even if I do PSQL, like I was doing now with the examples, I'm protected. So row-level security allows you to give that protection. So if we look at again at the requirement, we have seen that the first three are satisfied with these two policies. Hitchhikers can basically just work with their own reports for expenses. We still have this other two. Reviewers can see all reports, and the supervisors can approve the reports or reject them. If we translate the previous slide into users and roles, and in Postgres, we can see that hitchhikers can only submit access to their own data, and the hitchhikers are Arthur Dan, For Prefect, Trillian, French Church, and Rusta. So these are users, these are people. Yeah, so we can identify them with a name. Now, if we think in terms of reviewers and supervisors, this can have other kind of superpowers. Those are actually roles. These are not a name of a person. Yeah, so that's important. You have a reviewer as a role and a supervisor. So these are roles. And you also have the super users at the level of the database, like Postgres and the almighty Bob. And those just basically can do anything, and they don't respect all the things that you have defined above, which is normal. And I suggest that you never use a user Postgres for doing things. You always have to identify who is the one. So the same thing here, you never use the role reviewer or supervisor to do something. You have to grant these permissions to one of the users. So whenever you have an action, you know who did it. Yeah, so this can be audited. It's part of the all the security how's it called, certifications like PCI or CIS, right? So here, Almighty Bob is the one that you can use, and you grant these roles. Now, what are users and roles in Postgres? So users are roles. The only difference between the two is that a user can log in, yeah, and you only give access to login to names of people. So you don't give access to login to admin, because you don't know who is admin. You can become an admin once you are connected, yeah, but the password have to be only for users. So the user has password and they can log in. Now let's look at roles. Roles, you could see them as a group. Actually, it's one way of seeing it. It's not the only one. I think pgadmin see them as groups. But these are just tags, if you could say. It's a role that you play when you're doing something, right? And these can be assigned to other roles. So you can say grant reviewer to Fenchurch and grant supervisor to Marvin. Marvin is the paranoid android and the Hitchhiker's Guide to the Galaxy. When he knew that he had to do this task of a supervisor and then review all the expenses, he said something like, I will not enjoy it. The brain the size of a planet, and they asked me to supervise expenses report. But he had to do it anyway because he was so clever that he could do it much faster than anybody else. So reviewers can see all the reports. This is one of our requirements, right? So we're going to write a policy for this. And look at the difference here with the policy. It has two things. It has using and with check, yeah? So using, remember, that it was for reads, and with checks, it was for writes. So we have here the name of the policy, read-only reviewer, yeah? On what? The table expenses. Using, true. So it's always true. It doesn't matter what it is, always true. It can always read. With check, this is for writing, false. It doesn't matter what it attempts to do, it always fails. It's never able to write. Okay, so that's important. We don't even have to put conditions. We just say this is a result of whatever condition you have. And we assign it actually to a role. So we say to the role reviewer, you apply this policy. So this is new. Well, two things that are new here. We can combine using when we check, and we can also assign it to a role. Now, we are going to allow to read all the expenses Fenchurch. I remember in the previous slide, I said grant reviewer to Fenchurch, and this is what we are going to test later on. So later on, right now, I think, select current user. We see that the user is Fenchurch. Now we do select everything from expenses, and then she is able to see everything. Yeah, so you can see here, Hitchhiker is for prefect, Arthur then Trillion and different expenses. So you can see for prefect has everything on hold, whereas Arthur then is approved and Trillion is not yet approved. And this is being all decided by Marvin. Okay. Now you can see that there are 2,267,709, which by coincidence is the telephone number of a flat in London where Arthur then was having a very good party, and then when he met Trillion. Unfortunately, Staple Beaverbrook arrived there and he crashed the party and took Trillion away. So select current user now, Fenchurch. Let's try to approve something. She's a reviewer, so let's try to see what happens if she tries to approve the expenses report from Trillion, because she saw there was something new and she wanted to approve it. What does she get? Error. New row violates row level security policy for table expenses. Although she can do anything, we check it was false. So she could do anything by reading, but she couldn't do anything for writing. So we are protected again. This is thanks to the policy here. So you see, for reviewer, using true for reading, we check is false, right? Okay, now supervisors can approve reports. Now we have to create another policy for this. And the policy says that the almighty supervisors on table expenses, this policy is going to be applied to the supervisor role, is able to read everything and is able to write everything because it's using true as condition to read with a check of true after attempting to write. And this is all working well. So there you go. That's the policy. And we grant the supervisor to Marvin, which is very happy to do this task. Select current user, Marvin. Again, I'm just showing you that Marvin is going to execute this one. It says select everything from expenses. Exactly the same result as Fenchurch when she was reading. And he sees that Trillion has a new report that's not being approved yet. So you see the date is all 2019, because even though we think that Corona affected only planet Earth, it was actually something that affected the entire galaxy. So travels have been canceled everywhere. So Marvin is going to basically approve the report. And then he says, update expenses, state approve, where Hitchhiker Trillion. And then he updated 166 reports, just like that. So it works. Good, fine. Let me see now what Marvin wants to do with for prefect. He says, okay, I'm going to set the amount to 99 whenever the Hitchhiker is for prefect and the amount is larger than 99 Alterian dollars, because he knows that for prefect kind of submits a little bit too much, and actually he updated 1 million rows, right? So Marvin is a clever guy. Good. So we knew that we had already the first 3 requirements already covered. Now we can see that we have the other 2 requirements covered. So we're fine. We are making progress. Actually, there's all the progress that we can make on these requirements. So This was all thanks to the fact that we did all the security logic in the database. So we don't have to worry who is connecting to the database, whether this is something that is coming from the application or from PSQL, it is protected. That's the advantage. So what else is there? Let me see. If you want to have a look at the definition of the policies, because now I show you when I created them, but what if you connect to a database and you want to see what is going on? You can do \dep. This is for describe policies or privileges. I think it is privileges. And now the policy is being added. I didn't put all the columns here because, of course, this was going to overload the entire slide. So you can see here now only the policies, not the privileges. Okay, so we have the schema public, name of the table is expenses, the type is a table, name of the relation is a table expenses. And here we have all the policies that I defined, 4 of them. This is the one for allowing to edit your own expenses. You can see here this would check, hitchhiker is the same as the user, and the state is new. Yeah. Also to read, it is this one, using hitchhiker equal to the current user. And these are the other 2. As you can see, it's a combination of using and check, plus the fact that I can assign this to a role. Yeah. So I think this is a nice example of all the several possibilities that you have with role level security or row security policies, which is the official name. So something that you need to know is about dumping data. Let's say that you want to take a backup. Well, some people say the pgdump is not really a backup. You can export data to import it into something else. You need to create reports at the end of the month. So the best way to do it is just by calling pgdump, for instance. Let's say that user Ford Prefect wants to create a dump of the entire database Dodo expenses. Yeah, and it is connecting to the host Ursa Minor default port, and then it is going to output this into a SQL code, a SQL script called Ford.SQL. If you run this by default in version 13, you are going to get an error. It says pgdump error query failed because this query is a select query actually. It is affected by row level security on the table expenses. I don't have any other security policies here, but it fails for the expenses, right? And it tells me where it fails. Copy, the copy command actually, copy to, it needs to read. So it couldn't read on this table everything, so it fails. How do you fix this? Well, you add enable row security. It's exactly the same query, but now I do enable row security, and it completes. You see that it completed because I have now the prompt here that it appears again. Let's say exactly the same script now, except that now I'm going to output into Marvin.SQL. Remember that Marvin is a supervisor, so the user is now Marvin. It also completed, fine. And what I'm going to do now is I'm going to show you the output of looking at the list of files that I just created and the size of them. And as you can see, the size of the exactly same command here, it gives me 369 kilobytes for Marvin and 216 kilobytes for Ford. That means that this one is a completed dump. So if you have a database and you need to take some regular reports and you do it with a user that doesn't have the possibility to read all the data because of row level security, you might not get the entire output, like Ford in this case. So Ford could only see his own reports. There were plenty of them. So it was almost half of the entire expenses table. But there you go. Right. So let's get back to the subject of application users. Remember that I put a big question mark in the beginning? Something like this? Yeah. So we're going to talk about this a little bit because you say like, yeah, okay, fine, database users. But I want to do it with application users. Okay, so before I talk to that, I wanted to use this slide to mention about performance. Of course, if you need to add filters and check policies, things are going to run slightly less slow. It's going to be more. It's going to be slower than just running select everything from the table, of course. But if you make the comparison of performance, don't do a comparison of without row level security and with row level security, because this one is going to lose, of course. But this one, it is taking part of the job of the application away. So this job has to be done anyway. Yeah. So when you compare with row level security, do it application plus security asking the database without row level security, or application asking the database with row level security. In that way, you're going to really compare the two scenarios with security. If you compare security versus no security, of course, no security is going to be faster. So compare security with security, but two different approaches of security. Yeah. So when you have it there or there, but not just using this one versus this one. No, it has to be the entire picture, a holistic view of your entire application together with your database. Good. So there are different things here. One thing is when you connect to a session, you saw that I could change the user that I was making the examples. I was saying, like, I'm now going to become a user R210. Now I'm going to become user for prefect. Now I'm going to become FunCharge or Marvin. This is something that you can do with set role, okay? And this is something that you can do the web application or the Dodo expenses application if you want to. And this is how you can actually map your application users that are here with your database users. It doesn't matter how many, you can create millions of application so database users in Postgres. What you cannot do, it is to create millions of connections here to the database, right? That is going to be unscalable. So you have here the users that connect here, and then one application that connects here, but it doesn't have to be only one connection, but only one that connects there, and then switches role from time to time. It switches now an application that is for a query that is for the user R210, now another one for Trillion. And this is how this one is going to be actually playing different roles. It's switching from one role to the other. And you are matching your applications user to your database users. And then it's going to be all okay, all fine. Just don't want to have so many connections directly to the database. Okay. But there are some other ways of doing it. The other way is that you don't want to have your users be mapped to database users. You just want to have web app as database user and all the applications users are something else. Yeah, because you have not just 1 million users, you have several millions of users, right? In that case, well, you have to create your own table of hitchhikers, yeah, with more data, of course. This is an empty table. And instead of using create user Trillion, you have your users here on your table hitchhikers. And you have to manage your own way of doing login. Yeah, so the user could provide this password or two-phase authentication, whatever, or a synchronization with LDAP. You have the user that is being authenticated, and you have your sessions, cookies, or whatever at the level of the application. So you have to make sure that you have that on your application. Then, instead of saying set role Trillion, as I was doing in my examples, you will need to have a way of setting a username or a role or whatever in a safe way, which is encapsulated from any other user that wants to do this dynamically. Because if they have a way of getting to your database and running whatever they want to run, they could become any user. So you need to have a way to have a vault. And this vault is going to be in combination with some passphrase to authenticate a user. You can say, okay, now I'm going to set a username with this function here. So you have to create this function that works together with your vault that contains a secret. You can use pgcrypto for this. And this is going to be equivalent to have the set role Trillion here. Yeah. And then instead of saying, oh, I made a mistake here. This is not current username. This is select current user. Yeah. So the current user that we've been using during the whole presentation, instead of using that particular one that is part of PostgreSQL, so this is all based on PostgreSQL. This is all based on the application data that you're using. You're going to have another function which is called get username. And this get username is going to get the username that is being set here per session. So in each session, you set your username. This is a session variables that you can access from this one. And like that, you can emulate this kind of behavior here. And this is how you can actually have your own users at the level of the application instead of at the level of Postgres. I'm not going to give you a lot more details about this because this is really application specific. Django has a lot of good ways of doing this. There is a very good blog post from Thomas Vondra. So if you search for row level security second quadrant, Thomas Wonder has an excellent blog post about this, and he even has a GitHub project where he provides a full example of doing this. So you can check that out. Now, once you have that, so remember that's the mapping. But instead of having the current user, sorry about the typo there, you have get username. So your policies have to be different now. Instead of saying check on expenses on table expenses using hitchhikers equal to current user, now you have to say equals to get username. And then it's going to be exactly the same for the right policies. Instead of saying hitchhikers equal to current user, oh, I made a mistake here. So this should have been get username and state new. So I'm going to have to use the function here instead of the current user. I'm going to patch these slides before I made them available, okay? So don't worry about that. Right, so this is how you do it. Now the finale, instead of having the conclusions, I'm going to show you the final observations. In my understanding, not that I'm a very good developer in software, but I like the architecturally this analysis, the fact that if I put logic of the security in my database, I'm not only protecting it at the level of the application, but also protecting my database entirely that is coming from different sources here, or if I open my API in order to provide some other applications to also work with the same kind of data. Yeah, so I like that. And this is what you can achieve by adding row-level security. Now, if I want to show you a summary of what you can do, well, I think this slide is actually quite good in terms of showing you can have some right policies that can pretend from doing things that you don't want other people to do. So this is going to work only if this is satisfied. Also read policies, yeah, using here, and then combine and based on roles, yeah. And each of these policies are actually booleans. So whatever you put here in the conditions have to be a boolean. When you combine them, I mean, all the using have to be an OR operation. And when you're combining using and with check, it has to be an AND operation of the result of the OR, right? So this is what you can do actually with row-level security. And finally, I was able to provide protection for all the requirements that I put at the beginning of the presentation. Of course, I decided what were the requirements, so I knew that I was going to succeed them all. But actually, I don't think that I thought about something that was obviously not being possible to do with row-level security in this small example, of course. There might be some limitations, obviously. But for this particular example, it was kind of like, yeah, I can do this. Oh, I can do this. Oh, maybe if I add this one, okay, now. And then you can have like multiple things you can actually cover with row-level security. So that's one of the reasons why I have fun making this presentation. The other reason is because, sadly enough, it is 20 years since the unequaled Douglas Adams passed away. He passed away on the 11th of May of 2001. So the day before yesterday was 20 years since his death. And people at that time didn't want to wait for another year just to commemorate his death. No, they said, like, okay, in 2 weeks' time, we are going to all carry a towel with us. And my towel is there. I don't want to stand up now. And to honor his work, Douglas Adams, one of the greatest authors. It's not really a science fiction author. I think he's very good at analyzing human society, and he also talks about a lot about technology and stuff like that. So he combines the whole stuff, but this is all about human society, I would say. So if you appreciate also his work, the 25th of May, we're going to be having our towel day, and carry your towel and hitchhike the galaxy with us. So there you go. That's my presentation. Thank you very much, and thank you for listening. And I'm going to have a look at the possible questions on the chat, or the questions and answers stuff. So let me see the sessions. Okay, so there's a comment from Leo. If you want to have some feedback, please provide feedback. It is the only way that we can improve our presentations and improve the conference in general, is by getting feedback. If we don't get feedback, it's impossible to know what can be done better next time. If you have some other feedback to provide through Twitter, you can find me on Twitter. Nickname is Chorix. I'm going to be trying to answer all the questions if you have them later on. But if you don't have more questions, then if you don't have questions, we can leave it here. And thank you for listening. I think it's it's a good feature of PostgreSQL to have row-level security. So thank you very much. I'm going to wait here for more minutes if you want to ask something about row-level security. So I'm going to mute myself for the moment and then keep on reading the chat.